Welcome to Solutions Studio. This is a free series on C programming language. If you like these videos, please subscribe to follow along with this series. Also, please like and leave a comment and share the video to help spread this series. In this episode, we have a problem to solve. The name of the problem is Class Average Problem. So the problem is that if a class of 10 students took a quiz, the grades integers in the range of 0 to 100 for this quiz are available to you. Determine the class average on the quiz. So let's use a pseudocode to list the things that we need to do and say in what order we should do them. The first thing that we would do is that we will put in the grades one at a time using a counter-controlled iteration. This method uses a variable called counter to tell a set of statements how many times to run. So we do have the pseudocode in here for this problem. First, we create a variable called total and we set the total to 0. Then we create a variable called grade and we set the grade counter to 1. And then we create a while loop. While grade counter is less than or equal to 10, do the following lines, do the following statements. Input the next grade, add the grade into the total, and add 1 to the grade counter. So the first time when the user inputs the next grade, that grade is going to be added into the total and 1 is going to be added to the grade counter. So for example, if the next grade was 5, the total will become 5 and the grade counter will become 2. Now while again we'll check for the condition and it will see that grade counter is 2, it's still less than or equal to 10, so it's true, so it will run this part of the program again and it will keep running until the grade counter becomes 10, and then it will stop and we'll go to the next lines of code and we'll set the class average to the total divided by 10, and at the end we'll print the class average. So basically this is the pseudocode that, based on this pseudocode, we will create our program in the next episode. So stay tuned for the next episode and see you. Let's go and write the program that we had written the pseudocode for in the previous episode. So let's get started. You can see that based on the pseudocode, I have defined the two variables, which is the total and the grade counter, and I have initialized it based on the pseudocode values. Now based on the pseudocode, I have created the while loop. The while loop will check for the condition whether grade counter is less than or equal to 10. Sorry, I have forgotten to make it 10, so it's 10 here. And then the statements inside the while loop will be executed. A message will prompt the user to enter a grade, then a variable is created by the name of grade and it's set to 0. Then using scanf, the number that was entered by the user is stored in grade. The value of grade is added to the total and 1 is added to the counter. Now counter has become 2. Initially it was 1, now it has become 2, and we go and we start with the while condition once again. Is counter less than 10? Yes, it's 2, it's less than 10, so these lines will execute once again. Again, a prompt will appear for the user asking for grade. Grade will be initialized to 0. we get the grade and we put it into this variable. We add this variable to the total that previously it had a value. Now we add the new grade value to the total once again, and total will have the grade of 2 students, and counter will increase by 1 once again, and it will become 3, and this will repeat until counter becomes 10, and while loop will exit and the next lines of code will continue. Finally, we want to find the average. So average is equal to total divided by 10, because we had 10 students, and the while counter also run the while 10 times. And once we have the value of average, we print it with printf. And that's it, our program is completed. Now let's go and run it. The first grade is 98. As you can see, now we have the class average, and the class average is 81. And that's it for this episode. See you in the next one. Hello and welcome to this episode. In this episode we discuss about garbage value and why it's very important to always initialize your variables. So as you can see here, I have declared 3 variables: integer 1, integer 2 and integer 3, and I'm trying to print their values, but I have not initialized any one of them. Let's go and see the results. You can see the results in here that one of the variables has a value of 0, another one has a value of 16, and another one a value of 0. Why the second one has a value of 16 even though we have not initialized it to any value? Well, this is called the garbage value. You know that variables are like location holders in memory, and when we have declared integer 2, it has taken some space in memory. But that space was not cleared and it was not initialized, and the previous value in that part of the memory was 16, and that's why now we can see 16, because it was left from some other time from the past in that part of memory. It's a leftover value in that space of memory, and it's called a garbage value. And now you understand why it's very important to initialize your variables. For example, let's consider our previous episode's code. In here, if I had not initialized my total to 0, and during the while statement, you can see that the value of total is being added with grade. Suppose that if this total was not initialized to 0, it would have had a previous value, and that value would have been added to grade, and at the end we would have a wrong result. And that's why, as I said before, very important to initialize your variables. That's it for this episode. See you in the Hello and welcome to this episode. In this episode we discuss about sentinel value and why sentinel value is very important. So let's consider this example and this program. This problem is asking us to develop a class averaging problem that will process an arbitrary number of grades each time the program is run. So in this example, the user can enter any number of grades because it says an arbitrary number of grades. So how does the program stop entering grades? How will it determine and print the class average? Well, for this question, the answer is a sentinel value. A sentinel value is one way to show end of data entry. So a sentinel value is also called a signal value, a dummy value, or a flag value. The user types in grades until all of the correct ones are in. Then the user types the sentinel value to show that the last grade has been entered. Sentinel controlled iterations are sometimes called infinite iterations as well, because the number of iterations is not known before the loop starts running. An important point to remember is that you should pick a sentinel value that can't be mistaken for a valid input value. Since quiz scores cannot be negative, we can select -1 as a good sentinel value for this problem. So when the class average program is run, it might get numbers like 95, 96, 75, 74, 89, and then -1. The program would then figure out the class average for grades like 95, 96, 75, 74, and 89, and then prints them out. The sentinel value of -1 will not be included and used in the calculation to find the average, and it will only be used to flag the end of data entry. And that's basically what a sentinel value is. Stay tuned as we go into more details in the coming episodes, and we will create C programs using sentinel values. And specifically, we will create the example that we were given in this episode. Hello and welcome to this episode. We had this problem from our previous episodes that was asking us to develop a class averaging program that will process an arbitrary number of grades each time the program is run. So to solve and create the program for this problem, we use a method called the top-down stepwise refinement, and this method is very essential to make very well-structured programs. We start with the representation of the top in pseudocode, and the pseudocode for that is determine the class average for the quiz. The top is a single sentence that describes how the program works as a whole. So in a sense, the top is a full representation of the program, but unfortunately the top rarely gives enough information for the C program to be written, so now we start the process of getting better. We break up the top into smaller tasks and write them down in the order they need to be done. This leads to our first refinement of the pseudocode, which is initialize the variables, input, sum and count the quiz grades, and then calculate and print the class average. Here, only the sequence structure is used. Now this means that the steps should be done in the order that they were listed. Each refinement that we will create in the next episodes, along with the current refinement that we have, gives us a full description of the algorithm, but the only difference is that the level of details. So in here we don't have much details, but in the coming episodes where we will have more refinement, we will have more details until a point where we will be able to convert the pseudocode into real C program language code. And that's it for this episode. Stay tuned as we develop our further refinement of this program. Hello and welcome to this episode. So in this episode we have our second refinement of the problem that we were previously discussing in the previous episodes. We had initially created this pseudocode. Now we want to convert this pseudocode into more refinements. Now the first line of pseudocode in here, initialize variables, is converted into these two lines of code, which is to initialize total to 0 and initialize counter to 0. Only the total and the counter variables were needed to be initialized. The variables for the calculated average and the grade, these are inputs, didn't needed to be initialized because their values will be calculated and input from the user respectively. Now the second line of our previously created pseudocode is converted into these 4 or 5 lines. The second line needed a structure that goes through each grade one at a time. And for that we have used the sentinel controlled iteration because we don't know how many grades needs to be processed. The user will put in valid grades one by one, and finally the user will type the sentinel value after putting in the last valid grade. After each grade is typed in, the program will check for this value and ends the loop when the sentinel is typed in. And finally, the last part of this pseudocode is converted into more refinement with these lines of pseudocode. So in these lines of pseudocode, we are being careful to check for division by 0 because it is a fatal error. Division by 0 is a fatal error, and if it's not caught, will cause the program to fail, which is called crashing. So instead of letting the fatal error to happen, we test for this case and handle it in our program in the right way, like by printing an error message. As you can see, that has happened in here. Stay tuned for our further refinements of this problem. In this episode, let's go and talk about the number of pseudocode refinements that we need to solve a problem. So as you can see, we developed this pseudocode in the previous episodes, and the above pseudocode algorithm solves the class average problem. 2 refinements was enough to solve this problem, but sometimes more levels are needed. The top-down stepwise refinement process ends when the pseudocode algorithm provides enough detail to directly convert it to C programming language. So creating a working C program is easy when you have a correct algorithm already in hand. Many programmers never use pseudocode because they think that writing a pseudocode will delay their final output and product. However, this may work for small programs. It can never work for industry scale programs and software systems, and for that we always need a formal development process to be used. And that's it for this episode. See you in the next episode, where we will be converting this pseudocode into actual C program. In this episode, let's go and talk about the phases in a basic program. So basically, many programs that we have written until now, they have been basic programs, and many of those programs can be divided logically into 3 phases. An initialization phase that initializes to program variables. Then we would have a processing phase that inputs data values and adjusts program variables accordingly. And finally, we would have a termination phase that calculates and prints the final results. Going on in the coming episodes, you will also see that many of the programs that we will write and code will be consisting of these 3 phases. And we will be pointing out those phases for you in those episodes. So that's it for this episode. See you in the next episodes. Hello and welcome to this episode. So you know that we created this pseudocode from the previous episodes, and now we want to convert it into a real C program. So let's get started. I have declared my variables and I've also initialized them as we had seen in the pseudocode. Let's go and continue. Now I'm converting this line of pseudocode into a real C program code, and using printf I'm prompting the user to enter the grades, but only if they use the sentinel value of -1, this program will end. Now I have initialized a grade that I will store the grade that the user entered, and I will store it into this variable called grade. And now I have created this part of pseudocode, the while iteration part. So while grade is not equal to -1, what you would do that is to add the grade that was received from the user and add it to the total. Then you will increase counter by 1 and then prompt the user to keep entering the grade, and the program will keep storing that grade into this variable, and this loop while will keep running until -1 is entered by the user. Now let's go and continue. Now here in the if statement, we are making sure that counter is not equal to 0. So if the counter is not equal to 0, create a variable called average, and the type of the variable is going to be a double type, which will store floating points. And then we will do this calculation. We will divide total by counter, and we will cast the result of this calculation to be of the type double, because you know that total is an integer and counter is also an integer. So the result of their division is going to be integer, but by using this casting operator, we are forcing this calculation to be of type double, and we will store the result in this variable called average. Then we print the result of the average on the screen using printf, and if counter was equal to 0, that is captured in the else part, then we will say that no grades were entered. This is also very important because it's preventing from a logical error, and that logical error is that if counter is equal to 0 and we try to divide total by counter while counter is 0, and it will result in a bug and the program will crash. Now let's go and test our program. Now you can see that we have made a mistake. Let's go and find our mistake. You can see that I have forgotten to add the variable in the printf statement. Let me add it. And now let's go and execute the program. 10, 20, 30, 40. And now the sentinel value of -1 to end the program. And as you can see, the class average is 25. Let's go and try out some values so that result would be a floating point number. That's it for this episode. Stay tuned as we will be covering the details of this program in more details in the coming. Hello and welcome to this episode, and in this episode I want to emphasize the importance of braces while using while statements. So imagine that we don't have these braces. What's going to happen? The thing that's going to happen is that only this statement will belong to while and the rest of these statements will be out of the while's body. So they become something like this, if we want to show it with indentation. And the while will create an infinite loop, and it will never get out of the loop because grade and this scanf is out of the while's body. Let's go and give it a try. Now if I enter the first number, and now the infinite loop has already occurred, and the prompt for the second number will never appear for me because while is stuck on an infinite loop. Let's go and see the task manager, and you will see that while is consuming quite a lot of resources from CPU. Now you can see that the average program is using a lot of my CPU even though it's not doing anything, and that is because it is stuck in an infinite loop. So always try to include braces in your while statements and never forget about them. Hello and welcome to this episode, and in this episode we discuss about converting between variable types explicitly and implicitly. If you have been following from the previous episodes, you know that in the previous episode we calculated some average values. And you know that average values, they often contain fractions. Now it's important to know that the type double represents these floating point numbers or fractions. Since total and counter are integer variables, total and counter, the calculation total divided by counter in the line 7 will yield an integer. Even though we have defined average as a double, this calculation would yield an integer because the type of total and counter is integer. And in integer divisions, fractional parts are eliminated. So C language can create a temporary floating point numbers to perform integer-based floating point calculations using an operator that's called cast operator, and this operator is a unary operator. It means that it only takes one operand. So line 16, as you can see in here, that we have used a casting operator, creates a floating point copy of the variable total using the cast operator double. And the variable total will still remain an integer, but only a copy of it will be created, and this is called an XSplit conversion with a cast operator. So a floating point value of the variable total, which is a temporary double version of total, is then divided by the integer value in counter. And now we have these two variables as double, which is average is double, and we have explicitly converted total to double, but we have counter still as integer. And for calculations to happen, C only requires identical operand data types in arithmetic expressions, even though we do not have identical operand data types in this equation. This one is double and this one is integer. So in mixed type situations, the compiler implicitly converts selected operands to the same type. So in our expression in here, with the variable types of integer and double, C implicitly converts integer into double, and that is called an implicit conversion. And for this calculation to happen, you know that we explicitly converted total into a double type variable. The compiler implicitly made a double copy of counter, and finally the floating point division will happen and the floating point value will be assigned to average. And that's how calculations would happen in statements like this. That's it for this episode. See you in the next episode, where we will be discussing about cast operator in more detail. In this episode, let's go and discuss about the cast operator. You know from the last episode that C language's unary cast operator creates a floating point copy of the total of the variable total in here using the cast operator double, even though the original value of total remains an integer. And this is called an explicit conversion with a cast operator. So cast operators are made by putting a type name inside of a parenthesis. You know that a double is a type of a variable, and we have put it inside a parenthesis, and that will make it a cast operator. A cast operator is a unary operator, and this means that they only take one argument. Also remember that plus sign and minus sign, they are also unary operators in C. So you can write expressions like -7 or +5. And remember that cast operators, they evaluate and group from right to left. And they have the same order of precedence just as the other unary operators, plus and minus. This level of precedence for cast operators and other unary operators is one level higher than that of the multiplicative operators such as multiplication, division, or mode. And that's it about the cast operator. See you in the coming episodes. So in this episode we discuss about formatting floating point numbers. You know that in our previous episodes we used this line of code and we tried to show the class average using a floating point number average. Now as you can see that we have an if in here, and the if tells the computer to print a value with a floating point number. The point 2 that we have in here is the precision, and it means that the value will have 2 digits to the right of the decimal point for accuracy and precision. So when printing a floating point value with accuracy, the value is rounded to the number of decimal points or places that we have specified, but the real value will not be changed in memory. It's only that the representation of the value will change, but the real value will not be changed in memory. Let's look at these two examples. One has a .2 specification and one has a .1 specification, and you can see that they would result in such a display. And that's it for this episode. See you. In this episode, let's go and take a few notes about floating point numbers. So floating point numbers are not always 100% precise all the time, but they still have numerous applications and they are useful. For example, a normal body temperature of 98.6 degrees Fahrenheit does not need to be very precise to many digits. Thermometers may read 98.5999 something instead of 98.6. But 98.6 is still fine for most applications, and we will discuss on this later on. Also very important that divisions create floating point numbers most of the time. Dividing 10 by 3 yields a result of 3.333333 going on with 3's repeating infinitely. The computer stores floating point values in a fixed amount of space, so they are only approximation. So assuming floating point numbers are precise can lead to incorrect results. Because computers approximate floating point numbers, therefore we don't compare floating point values for equality and we don't use them for such application. Stay tuned for more on C programming language.